Hi everyone. Hi Diego. How you doing there?
Hello, ciao, amici italiani.
Ciao.
How are you doing?
Hola, hola Diego. We are here for the first time on hybrid meetup with a bunch of people here attending. So show you make some noise. Make some noise, folks.
Uh,
Yeah,
this
yeah.
is really nice to have some people in front
This really yeah.
in
Yeah,
a real room.
we have a big television here in front of us so people can watch the session live. We have StreamYard streaming the video on YouTube. This is kind of a new setup for us, but I think it's going places. So nice. Thanks, Diego, for accepting the invitation, and thanks for the great session I'm going to give.
I'd love to be there in person, but as a substitute, I think this will be nice. Thanks
Yeah,
very much for
next time.
inviting me.
No, thanks, Diego. Next time, next time. A few people are welcoming us, saying something. Buonasera by Julian and Rui. Hola, okay, hola, guys. And Leonardo, buonasera a tutti. Okay, I think we can start the session, Diego, and
Sure,
let's try this very first form of a hybrid meetup for the Italian C++ community. Thanks, Diego.
perfect.
I'll
Thank
add
you,
this to
Marco.
this.
Thank you, everyone. So yeah, my name is Diego, and I am one of the Conan co-founders. And today I'm going to give you an introduction to Conan, but I wanted to prepare something special. So today's session has two parts. The first one is let's say the relatively easy and common stuff, which is using existing packages first, packages that someone created for us, and we're just going to consume them and use them. And then we are going to learn how to create our own package and upload it to our own server. But I am going to do this part with all the new integrations. I'm going to do a special focus on the Cmake transparent integration that we have already released, is available today in Conan 140 and Conan 141. So I'm going to explain this new integration for this flow. And then for the most advanced users, I'm going to explain two advanced use cases. The first one is how can you work on multiple packages, the source code, changing the source code of multiple packages at the same time, which is the editable feature. And also going to do a demo of cross-building with the build and host profile to enable advanced cross-building scenarios. So let's start first with a brief introduction for those that are newbies to Conan. Conan is a package manager from C and C++. It is open source, MIT license, so you can do with it whatever you want. It runs in any platform and can target any platform. Actually, today we are going to cross-build to Android, for example. It can integrate with any build system. I'm going to use today a lot of Cmake, but even if you have Visual Studio, and I mean native Visual Studio solutions, or Makefiles, or Meson, or even your proprietary build system, Conan can use it. It is a stable project. It has been running in Conan 1 from 1.0 to Conan 1.41 versions, one release per month without breaking. And it has a very active and amazing community, really helpful in ConanCenter creating packages, doing contributions, helping each other in the Slack and Discord channels. So the community is one of the best things of Conan. Regarding the architecture, Conan is using the typical server client architecture, the centralized architecture. So we have the JFrog ConanCenter repo, which is a server that contains the packages of popular open source libraries. These are the packages that the community is creating, is contributing them to the center, so they are available for other users. But you can very easily host your own JFrog Artifactory instance. We have a community edition, which is completely free. And if you want to store there your own packages, your own private packages for free, you can do it. And then you can have the client that is downloading packages from ConanCenter or from your own Artifactory instance, or both if you want. One of the most important features of Conan is the way that it manages the binaries. And we will see today in action, but I wanted to give the big picture first. For every package, we have a recipe. A recipe is a Python script that describes how a package is built from sources and packaged from sources. Okay. Every recipe can create any number of binaries. For every different configuration, every different platform or compiler, that recipe will create its own binary. And Conan will store and manage all those binaries connected to the recipe that created them. together. If we focus a little bit more on this model, we can introduce the package ID concept. Okay. The package ID concept is a hash. It's the hash of the configuration that is used to create that binary. So for a given recipe, let's say in this case, the mylib 1.0 recipe, that Python script, if we build this package with a set of options, for example, we here in the right side, we can see a set of options. The settings is the compiler, the operating system, the architecture, the build type, compiler version, and if it is a static or a shared library. Okay, we take this configuration, we hash it, and then we get the first package ID. If we change something in this configuration, for example, we change it from being a static library to being a shared library, then the binary will be different. And we will get a different package ID because hashing the contents of the configuration results in a different hash and a different package ID. And also, if we now change the build type from release to debug, the binary is a different one, and it will be managed under a different package ID because the hash of the configuration is also a new hash. Okay, this concept is very important. We will see today live in action. We will be creating packages for different configurations and see how it works. Creating multiple binaries for the same package doesn't mean that Conan is inefficient. Actually, Conan is very efficient because when you're building, when you require a package, and you can have, even if you want 100 different binaries in the server. Actually, we do. In ConanCenter, we are building binaries for more than 100 different configurations for these open source libraries. But when you are installing and when you need to build your application and you do a Conan install, only the binary for your configuration is downloaded. This means that working as a developer is fast and efficient, and also for CI jobs, it's very efficient because you only download exactly what you need for that specific build. The other important concept of Conan is that it abstracts away build systems. As I've said, we are going to use today Cmake a lot, but it is not compulsory. You can have different packages using different build systems, and this is actually what we have in ConanCenter. We have all these packages. They are not using always Cmake to be built. They are using different build systems. So you can create packages with any build system, and you can consume those packages with any other build system, not necessarily the same one, and you can mix them. We will see then later how it works. Okay, so as you can guess, I don't love slides. I've gone fast through them, and I'm going to start the live demo. Hopefully everything goes well. I'm going to start with the example of how to use existing packages that someone created for us, and I'm going to show two examples. First using libcurl, and then using Cmake. Cool. Here I have some code. This code, I have it in a GitHub repo. If you are interested, I will share the GitHub repo after today meetup. Okay, so I'm going to introduce you to this little example here. I'm going to build a small application. An application that is going to do an HTTP GET request to a server. And for doing this, I'm going to use the libcurl library. This is the main. It has nothing special, just using the curl library. In this case, it's doing a GET to a URL that is being specified in the command line and printing the results of the GET HTTP request. This is not very relevant for us today. What is really relevant for us today is this. This is the Cmake list to build my application. As you can see here, there is absolutely nothing related to Conan in this Cmake list. It's absolutely agnostic to Conan. But we are going to use Conan dependencies, but you don't need to modify your Cmake list to account for these dependencies. Okay, what we need to do is we need to tell Conan that we need to install, we want to fetch the libcurl library from, in this case, from ConanCenter, and I need to specify which version I want to use. So for this, I'm going to write a conanfile.txt file, which is the simplest form of a Conan file. The first important section that I'm going to specify here is the requires. I specify here the packages that I want. In this case, I want libcurl, and I want this specific version. You can specify an older version if you need it, or the latest one, as you wish. And finally, I'm going also to specify my build system. In this case, I'm using Cmake, so I want Conan to generate the necessary files to integrate with my Cmake build. In this case, I want to generate files for my dependencies, and I want Cmake to generate a toolchain file so I can call it transparently. So this is all I need for Conan to install my dependencies. Let's do it. Let's create a build folder. And I'm going to call Conan install. Conan install, the first thing that you will see here, okay, is that Conan install is installing a few things. It's installing not only libcurl, but it's also installing other libraries. Why? Because those are transitive dependencies of libcurl. So if I inspect, I actually can print my dependency graph. I can see that this is what I have. I have dependent on libcurl, but libcurl transitively depends on OpenSSL and setlib. And this is the reason why when I did Conan install, the three dependencies were required. Then this was very fast. Why? Because Conan found binaries for my configuration, precompiled binaries in ConanCenter for my configuration. As you can see, I'm using Windows. Why? Because typically, let's be honest, it's the most challenging platform. If I can make this work in Windows, it probably works in the other platforms. Conan works exactly the same in all the platforms. You move to Linux, and this demo works exactly the same. Okay, same commands, same everything, and it will also work. So yeah, I got precompiled binaries, so they were downloaded. Everything was very fast, and finally, as I specified the generator Cmake depths and Cmake toolchain, Conan generated some files for me. Actually, it generated some config files for the different libraries, OpenSSL, setlib, curl, so these dependencies can be correctly found, and it generated a Conan toolchain.cmake for me. Then from now, it's just a standard Cmake stuff. I could do Conan toolchain. This will create a project. This will launch the Cmake configuration step. In this case, as I'm using Windows and Visual Studio, it's going to generate a Visual Studio project. Of course, I could open the IDE and build from my IDE, but in this case, I'm going to build from the command line, which is a bit more convenient for demo purposes. This will be building my curl application, and now I could run my application. Yes, it seems doing something. Okay, I didn't provide a URL. Let me check. Yeah, this one, for example. As many developers, I guess some of you, who loves cats? Someone? Raise your hands. Loving cat lovers there? No one? Yeah, some of them. I guess so. We can ping this, do a GET request to this URL that contains some cat facts. And if everything works, we should see here a fact, some notable people who disliked cats: Napoleon Bonaparte, Eisenhower, Hitler. Okay, good. It seems that our application is running and is working. Okay, nice. So we built our first application using some Conan dependencies, which was a library. We use, sorry, Marco, do you have any question there? No, I don't hear you, by the way.
No, Diego, it's no questions here. I was trying to enable the microphone of the laptop, but this way you get some return noise, so I can't do it. So if people have questions, I can just pass the headphones. No, sorry for the interruption.
Okay. Sorry. No problem. Just let me know. Okay, so I was saying that we have used a library. Okay, but very soon, in the very first version of Conan, people started asking us, hey, what if I put an application like Cmake itself into a Conan package? Can I use it later? And then this resulted in the concept of build requires. Okay, and now it happens that we have some tools packaged in ConanCenter, and you can also package your own tools, whatever you need, as Conan packages, and then you can use them as build requires. A very important concept here. Conan does not modify your system. It will not install Cmake at the system level. And to be able to use this Cmake 320, I need to enable a virtual environment. And I'm going to do this via the build environment generator. And I will show you how it works. Okay, so now I've specified that when I'm going to install, let's do it again. Now, my application will depend on libcurl, OpenSSL, and setlib as it did before, of course. I haven't removed this dependency, but now, as build requirement, it is depending on Cmake 320. Okay, now it is unzipping Cmake 320. Let's give it a second to finish. Okay, it did finish. The last run, when I built my curl application, I was using my system Cmake, which is, you can see that I have here in my system, I have installed Cmake, and this Cmake is 3.15. So this was the Cmake that was built in my previous curl application. Okay, now I have installed Cmake 320 as a build required. Okay, it didn't modify the system yet. What it did for me, it generated a script with environment variable. I can do run now Conan build.bat. It changed the environment. So now if I ask, hey, which Cmake? And we can see that this is pointing to a Cmake 320 that is inside the Conan cache. So whenever I run now Cmake, it's going to be 320. Okay, so I could build now my application, everything will be running Cmake 320. You can install in parallel as many Cmake versions as you want. And if at any point you want to return to the previous one, you deactivate the environment, and then you are back to the system Cmake. Okay, so this is a powerful feature which is called the build requires. You can put tools there and then use them very, very easily as well. We will use these build requires again in the cross build example. Any questions so far? Okay, let's do then a brief recap of what we have done. We have learned how to write a Conan file.txt and call Conan install to install dependencies and transitive dependencies. From there, we can just call Cmake, native Cmake, passing the Conan toolchain, and then everything will work. We have seen that the Cmake toolchain and Cmake devs new integrations, they can provide a fully transparent integration. That means that you don't need to modify your Cmake list at all. We have also learned how to use build requires and activate the environment to activate those tools without changing your system. Many thanks to the creator of these packages. Now in the ConanCenter, there are more than 1,000 recipes. Every recipe can contain multiple versions, and every version can contain more than 100 binaries. So this is created by the community, an amazing community. So many thanks to these people. If you don't find a binary in ConanCenter for your configuration, the recipes themselves, they know how to build from sources. So if you do a Conan install and it tells you, hey, I don't have a binary for this configuration, then you need to add Conan install -- build to force a build from sources. And then it will launch a build from sources for the packages that don't contain the binaries in ConanCenter. Okay, then now let's move to learning how to create our own packages. Right? And then we are going to have a library. We are going to create a package for it, and then we are going to upload this package and the binaries to our own server. Let's go to the source code. And then I'm going, sorry, give me 1 second to clean this up for later. Okay, this is the library that I want to create a package for. This is a very example one, sorry, a very simple one, a hello world one, just a single function, and this function will contain some output to std out, some messages, hello messages, and also some diagnostics about the architecture, the compiler, and everything, just to make sure that everything is working correctly. Okay, so very simple C++ library, hello world library. Again, now that we are using the transparent integration, the Cmake list to create a package is still your own one. It doesn't contain any Conan specifics here. Okay, this is a library from these sources. I'm building the hello library. The header of the library is this one. And then I'm using the Cmake install feature to specify which are the artifacts that form the final package of this library. Okay, nothing really different, nothing really Conan specific in this Cmake list. But let me introduce the Conan file.py to create a package. The Conan file.txt that we were using earlier is a very simplified form of this that is only used for consuming existing packages. If we want to create packages, we need to provide a Conan file.py recipe. This is a Python script that contains a few important sections that I'm going to summarize now. First one, the metadata, name and version of the package, for example. Next important part, the binary configuration. This is the binary model. This means if you are changing anything in your configuration, like the operating system, or the compiler, or the build type, or the architecture, you are going to get a different binary. And furthermore, inside compiler, there are compiler.version, compiler.runtime, compiler standard library that we don't need to declare here, but they are subsettings that also affect the binary configuration. Then we have the options. In this case, we are declaring that we can build a static or a shared library as we want. Okay, if we change any of those inputs, we will get a different binary. Let me skip these two parts here because they are not really relevant, and let me focus on the new stuff. These are the important methods of the recipe. Okay, let's start with the layout. The layout is a new feature. It's very new from Conan 139 and Conan 140 and 141, the latest releases. It is useful to specify where the things are. This predefined Cmake Layout function here specifies the typical Cmake layout. Typical Cmake layout will contain a Cmake list like this one in the root of the repository. When you call Cmake, it will be creating a certain structure of folders. This is what this Cmake layout is representing. You can customize this. The idea is that anytime you have something special, for example, you don't have the Cmake list in the root, then you can specify something like self folders.source equal source. You could do this, and then this means that you will have the Cmake list will be inside the source folder. And the root of your source is not the root of the repo, but the source folder. Okay, it's not very important to know all the details, yet that this method here represents the local structure of your source code and your project. Next method, the generate method. This is completely equivalent to the generator section that we saw in the Conan file.txt. In this case, we are telling that we want to a Conan toolchain.cmake file because we are going to use it. The important part here, and what I wanted to show this section, this method here, is because you can also customize a lot of things here. If you want to preprocessor directive, you could add here something. and a value. And there are ways that you can customize this Cmake toolchain at your will in this function. So if you want to inject your own values, change some of the Conan defaults, because the Cmake toolchain contains some default logic, you can customize it very, very deeply. The build method is a very thin wrapper around the Cmake command line. This Cmake configure is basically the same as running Cmake and passing the toolchain file, creating the project, and the Cmake build is basically the same as of calling Cmake --build. You could actually try it yourself, and you could replace something like self run Cmake --build, and it will do basically the same. So if you have here your own build system, it's just a matter of calling your build system with the arguments that you need to produce the build that you want. The package method exactly the same. The goal is once the build has finished, it will copy the artifacts from the build folder to the final package folder. This is a thin wrapper on the Cmake command line, which is equivalent to be calling the Cmake --install. And finally, this important package info method is the information for the consumers. This is the bit of information from Conan that's decoupled the build system. This is telling the consumers, hey, when you are using this package, you are going to link with a library that is called hello. Okay? If the library name changes, it's necessary to change this way. Why? Because Cmake information is not enough. If you are going to consume this package directly in Visual Studio, you need someone to tell Visual Studio the name of the library is hello.lib, and this is the place that this information will be contained. Cool. So with this recipe, creating a Conan package is calling Conan create and dot. With this command, it would be firing the different recipe methods, calling generate, generating the files, calling Cmake the build method. The build method will be calling first the configure step, creating the project for us. As you can see here, it is using my default configuration again. As I didn't specify anything special, it is creating the package for my default configuration. Finally, it's calling the package. And here we can see that the artifacts that are being put into the package are the header and the library itself. So if I do a Conan search, everything was local in my machine, of course. This is a local build that was produced in my Conan cache. If I do a Conan search, it will tell me that the recipes that I have in my cache are these ones. The previous ones that I used for the previous example, and then I have the hello 0.1 package in my local cache. If I further inspect the hello package, I will see that I have one binary, okay? The binary that was created for my default configuration, which is Visual Studio, 64 bits, dynamic runtime, compiler version is the 16, and so on. And this is the package ID, which is the hash of this, in a simplified way, but basically it is. Let's say that now I need to maintain this important library in my company, and we are deploying this library for some ATM machines that they happen to run in Windows, in an older Windows version, and which is 32 bits, and I need to run to link with the static runtime, and I need to use an older compiler version because new compiler versions won't run in that machine at all. So I can just repeat the Conan create process. And in this case, I'm going to specify the specifics. I'm going to say that my compiler version is to be 15 instead of 16. I'm going to tell that the compiler runtime is going to be the static one to be deployed in that ATM machine. And I'm going to specify, for example, that my architecture is going to be 32 bits because the place, the machine where this hello library will run for this binary will be 32 bits. And now the process of creating the package, calling the generate, calling the build method, calling the package method will be called again. In this case, we are using Visual Studio 15, and it will be passing the right parameters, the right arguments, like the architecture and so on. So the library is built correctly for this configuration. If we now specify sorry, if we now inspect again the package binaries that I have in my local Conan cache, I can see that I have these two different binaries. I will have my first binary for my native desktop system, and I have this binary, which is the one for the ATM machine, which is using the 15, 32 bits and runtime static. Furthermore, we can use, we can cross-build. For example, now we are going to cross-build to an Android application. Let's say that this same library is deployed in some Android application that we are maintaining as native code for efficiency. How to do this? So first, I could be launching this, and instead of this, I could be passing here is going to be an ARM v7, is going to be the operating system could be Android. As you can guess, this is not a very practical way of managing configurations. So instead of this, what I'm going to do is to use a profile file. This is the way that is recommended to use in production. When you are maintaining different binaries for different configurations, instead of passing them in the command line all the time, you need to put the settings and the configurations in a file like this one. And you want to use this file all the way. Conan has mechanisms to share this file, by the way. So this file can be put in the CI machines, in the developer's machine very easily. So here we can see that we have the settings for this binary, which is Android, API level 23, the compiler version, and so on. And now I want to introduce a new mechanism a new modern Conan mechanism, which is the new configuration that can be also defined in profiles. This is specifying things like, for example, where is my Android NDK? In this case, I installed the Android NDK in this path in my system, so it can be located. And also I want to specify that for this build, I want to use the Ninja generator instead of the MinGW, because Ninja, as we know, is fast and is very cool. So we can specify, just keep that there is a new mechanism for configuration. It's more powerful than we were using before, which was environment variables, and we're more structured. So with this profile, we could go to the command line and specify the profile instead of a bunch of settings and options in the command line, which is more error prone. So if we create the package now for the Android profile, we will see that the build, sorry about that, the build is now, sorry. Now, as you can see here, this is using the compiler that is within the Android NDK that are installed in the system. We can see that we are using the Ninja Cmake generator, and we can see here that the final binaries are being built. I can guarantee, I was just for curiosity, I was trying. I've tried to move these libraries and these applications built this way to an actual Android device, and it works. The integration with the Cmake of the Android NDK is pretty cool. So now, if I do a Conan search, I will see that I have these three different binaries. Okay, I will have the Android one here with this configuration and this package ID. I will have my Windows desktop one here, and I will also have the Windows ATM legacy 32 bits binary here. Okay, and this is the basics of the binary model. Now the thing is, okay, we created these three packages here in my computer, but what I want is I want to share these packages with my team and my company, so they can reuse them. They can use them in CI, so they don't need to rebuild over and over these libraries from sources, because in the real case, Hello will be a big library that takes a bunch of time to be compiled. So I want to share these packages with my team. So welcome to Artifactory. Okay, so Artifactory is the JFrog server. In this case, I'm using here Artifactory CE Community Edition, which is completely free for Conan packages. So you can use this commercially, professionally in your company, completely for free, both the client, which is MIT, and the server. Here we can see we have a Conan local repo. You can have as many repos as you want, and we can get the URL of this repo. And this is all we need to be able to upload packages to this repo. So I've already added this remote to my local Conan client, and now I can do a Conan upload. I will upload the hello package to my Artifactory remote, and I want to upload all the binaries that I did create. Yes, I do. So now Conan is uploading the binaries. Let's have a look at the Artifactory. And here we have the hello package. We have the hello package 0.0 version. If we go down a little bit in the folders, we will see that we have these three different binaries. If we further inspect them, we will see that we have the package for the Android here. We have the package for the Windows desktop machine, and we will have the package for the Windows for the ATM machine. Okay, and this is very cool because now even if you you need to manage many different Linux builds and different Linux distros and compiler versions. You want to introduce a new compiler version. You don't break anything. You just build the new binaries for the new compiler version. They are uploaded there. Previous builds with the previous compilers, they don't break. They keep using the previous compiler version, and then you can start just pushing a new compiler version very, very easily. Also, you will realize something, that besides the hello package, I have libcurl, OpenSSL, setlib, and Cmake here. This is something that you can do. Actually, it is recommended to do this. Instead of depending directly from ConanCenter, what I did today, just in case the network is wrong, demo effect, whatever, I didn't pull the artifacts directly from ConanCenter. I did a copy of the artifacts to my Artifactory instance, and now I am completely robust against any failure, and nothing can break. This is recommended for you in production. Even if you are going to use ConanCenter packages, having your own Artifactory instance, doing a copy there of the packages that you are using is a very good practice. It is the way that we want that the npm, the buckets of the left path and everything won't happen to us if we are doing these best practices. Excellent. So now that the hello packages are in the server, we could perfectly remove the hello package from my local client and not trace anymore. Perfect. So now the packages are there. That means that we can go back to the previous project. Remember the mycurl application? We are going now to use the hello package in the mycurl application. Let's do it. Let's see how it works to have a package manager in place. All I need to do is I need to include the hello.h. I'm going to call the hello function like here. This is managed in native Cmake syntax. So if you move hello to another mechanism not managed by Conan, this syntax will still be the same. Hello. And finally, I'm going to add the hello dependency here in my Conan file. That means that now if I do a Conan install, it's going to depend on hello. Okay, it's going to download the hello from the Artifactory. It's going to download the binary, directly the binary, no need to rebuild again. So if I now rebuild my application, I have just reused the library that I created from the Conan package from the server that was pulled into my local project. And I can see here the hello dependency doing its stuff and printing its messages. Okay, let's do a brief recap of what we have done. We have learned how to create packages, specify different settings, different configurations to create different binaries. We have learned about the profile and how using profile files is recommended to manage configuration. We have learned how to upload those packages and those binaries to our own Artifactory server, and how can we use these packages later in other projects in our teams or in our companies. This is, I already said, this is a good practice. Using Artifactory CE to have independent, isolated, efficient, and robust builds is a recommended practice. ConanCenter is very cool, but if you want to be rock solid, better use an Artifactory CE instance, both for third parties and your own private packages. Okay, so this was the basic stuff. We have learned how to use existing packages and how to create own packages. But now I'm going to move into a more advanced territory, which is more enterprise use cases. Vale, is something that many Conan users have been asking for. Is, hey, Diego, what happens now? I need to work on these two packages at the same time. I need to be changing the source code of the hello package and the micro package at the same time. And this can be painful because what we have done is we have modularized. We have completely decoupled micro from hello. They can have different versions. They can be developed independently. So this is what we have right now. We have the hello package and we have the micro application. Okay. Whenever we do source code changes to the hello package, then we need to do a Conan create, a new one. So this package is created in the cache and it is made available for the micro consumer. The builds in the cache are always from scratch. They are not incremental builds. The library, and this is very important, they guarantee that this is a clean build, this is always correct, and it cannot do incremental build in the cache. It will never do that. That means if the build in the hello library is heavy and takes a few minutes, this is very painful because you need to do the source code changes, Conan create, wait for a whole build, then go to my curl and build my curl again. Okay, so we heard developers. We really take feedback seriously. So this is one of the reasons we have been developing this issue and we have been iterating. If you knew about editables before, we have changed how they are used. So the first important bit. Okay, so what I really need is I want the hello package to be locally modified and locally built. Okay, I don't want to do a Conan create that is a build in the cache. I want to have my local flow as a developer of the hello package. The local flow means exactly the same as we did for micro, which means Conan install to install the dependencies of hello, because hello itself can have dependencies. Okay, and then call Cmake. This is what I'm going to do right now. I'm going to move to the create project, and I'm going to do exactly the same. Is typically create a folder, move to the folder, then do a Conan install. In this case, I also want to showcase one of the use cases that is important for, especially also for people using multi-configuration environments. In this case, Visual Studio. If you know a bit of Windows or Xcode, they are multi-configuration environments. That means that you can switch from debug to release directly in the IDE. Okay. As I want that experience, I'm going to install for the hello package, I'm going to install both configurations. I'm going to install the release one, which is the default, and I'm going to install the debug one as well. Okay, And then again, is I going to create my project, calling Cmake. This will generate my Visual Studio project and solution. This is exactly the same steps as I did for my core before. Is installing, calling Conan install, and calling Cmake to configure the project and build the things. I could build the release configuration of the Hello library, and I could build the debug one. Okay, everything is in place. This is what I got. Okay, but still, so far, if I now go to my core project, if I do a Conan install, it will still get the dependency from the cache. This is what can be changed with the Conan editable add. If I say this command, I'm telling, hey, whenever you find the hello 0.1, don't go to the cache, go to this folder. The folder is the dot folder, is the current folder. Because in this folder, you will find the release hello.lib, you will find the source hello.h that you need from there. So this is the thing, the important bit that changes the location of the dependent package. Let's do it. Conan editable add. Just in case, there are several Conan commands that you can use. For example, you can list the packages that you have in editable mode and where they are located. So in this case, you can see that this is my folder, and it is not a folder in the cache. Okay. So with this in place, I can go to the use build, and for the use break is just Conan install. When I do Conan install now, in the consumer project, in my cool project, this is what I will get. It will tell me that it still depends on libcurl, OpenSSL, and setlib. They are found in the cache, but now hello is not in the cache. Hello is an editable package. It is expected to be found in your local folder. Okay, I can do the same for build type equal debug. Okay, in this case, it's installing the debug dependencies as well. And from now, it's just the usual stuff, calling Cmake. And we're done. And now is when I wanted to show you. Now we have everything in place. We could be coding. We have the two projects connected. Okay, I could be typing from the terminal, but I want to show you that with a couple of clicks, what can be done. I'm going to open Visual Studio Solution. Okay, of the micro example. This will take a bit, of course. It's Visual Studio. And yeah, come on, Visual Studio. You can do it. Excellent. So one of the cool things of having IDEs and other tools is that you can do things like this one. You can say, hey, I'm going to add you the other project. And I'm going to tell you that this is a dependency. And we got it. Now we can be working for hours. Yes, it took a couple of clicks. It took to set up a little bit, but now I can be working in this setup for a few days. And now I will have both things in the same place. I can show you, I can execute the micro application. It is building from source. It will be launching. And here we can see that it is depending on the hello package, and it is also doing its stuff. And the cool thing that is now I can, of course, change the source code of the hello package of the dependency. I can type here by, and of course, it will do incremental builds. It will build what is necessary, and it will launch now the application, changing the message. And I can be working together with two or more. If you want to have several packages at the same time, you can do it. This is the multi-configuration stuff. You can change directly to debug in the IDE. Okay, and you can be also launching the debug configuration. You can build and change and launch the debug configuration. Here we will see now that we are running the debug configuration, including the dependency of the hello package, and we can step into, of course, we can debug. And we could launch our application, and it will go into the source code of the dependency. We can stop here, and then, of course, we could continue. And this is it. Okay. So this is the editable feature in action. And honestly, I'm really excited about this feature, because this is what achieves the best of both worlds. When you are using a package manager, you modularize things, you decouple things. And then there is the pain when you need to work, and this really happens in enterprise and in companies with huge projects, that they need to work on more than one package at a time. And this can be painful if the necessary tools are not there. With this, we are enabling these developers to have the best of both worlds. They can modularize their packages, have a very efficient CI, binary management, and whenever they need to be working on more than one package at a time, then they can do it. It takes a couple of clicks, and knowing a little bit. This is documented. This is not documented yet. This is very new stuff, and this will be the future of Conan. Conan 2.0 will implement this as the default. Okay. All of this works because of the new layout and Cmake layout that I was showing you earlier in the recipes. Okay. Good. Then I will finish my presentation today showing another interesting advanced example, which is cross-building with the build and host profile. Earlier, I was cross-building to Android, okay, and this was a relatively easy cross-build. Now I am going to put a more challenging example, which is the protobuf one. Let's say, and this is a simplification, but this is real. The protobuf example has this case. We have the protobuf 1.0 package, and inside this package we have two things. We have a library, a static library, protobuf.lib, for example, that contains most of the logic, and we also have a proto-C executable that is used to generate code. It's a code generator that needs to be used at build time. Okay. And this is challenging. Let me show you how it works. Let's say that we want to build an ATM server package, okay, for the ATM machine that we were talking earlier. And this server here is going to communicate with protobuf. So it's very clear that this ATM server package, we need to require the protobuf package, okay? And it needs to do this build with this profile, with the 32-bits architecture. Compiler is Visual Studio 15, and the static runtime. Both the ATM server 1.0 and the protobuf 1.0 containing the static library, they need to be built with these exact settings. Otherwise, they will produce link errors. Okay. But at the same time, while building ATM server, I need to be calling proto-C. This is a very common scenario, because I'm going to generate some source code, some C++ source code, from some proto file that has a declaration of the interfaces. Okay. The proto-C package that I'm running here is running in the build context. The build context is the place when I'm running the build, which is my computer. My computer is a 64-bit architecture, is Visual Studio 16, is using the runtime, while the host context, which is this is the GNU naming, by the way. The build context is my machine. When I'm doing the build, the host context is the place where the application is run. In this case, the ATM machine. Okay, so we have these two contexts, and now we have two profiles. We have the Windows PC profile, and we have the ATM Model 1 profile. This is way more evident if we do a full cross-building, and this also works the same way. We could be cross-building, for example, from Windows to a Linux machine here, and then the build context and the build profile will be Windows PC, and the host context and the host profile here will be a Linux context. That means that this protobuf 1.0 containing the library should be a Linux binary, a Linux library, and the protobuf 1.0 here in my build machine should be a Windows binary containing the proto-C executable. Okay, so this is what has been built into Conan. Let me show you this example code here. Here we have the two profiles. This is my Windows profile. Okay, this is my current build machine. And this one is the profile for the 32 bits architecture, which is the host machine, which is the ATM server. The protobuf package here is a standard one. It contains a protobuf proxy, which is printing some messages, and a proto-C proxy, which is also printing some other messages. Okay, this is not where the important stuff is. The important stuff is in the ATM server package. And this is the point. We are going to use both a requires and a build requires to protobuf. This requires is a requires of a library. It's a requires for the host context. Okay, it will depend, it will link with the protobuf library. The build requires is a require for the build context. This will bring the protobuf in my Windows build context to be able to run the proto-C executable. Here we can see that the build method of the ATM server recipe, it contains a call to the proto-C. This proto-C that is running here will be the proto-C inside the build requires. And as such, it should be run with the configuration of the build requires. And this is basically it. Let's do a Conan export protobuf to be sort of here, protobuf 1.0. And now let's move to the ATM server. And let's do a Conan create. So in the same way we specified previously an Android profile, now we can explicitly provide the two profiles. I'm going to specify that my build profile is my Windows PC and my host profile is this ATM profile. And I'm also do, okay, this is going to fail, okay, because I didn't create the protobuf binaries yet. The amazing thing is that I'm going to build with the -- build missing. What I'm going to force now is I'm going to do a build of protobuf in two different flavors in the same build. If I was doing cross-building, this will first build protobuf executable for Windows in a Windows build, and then it will build protobuf in Linux in a cross-build build. Okay, let's give it a couple of seconds so the output stabilizes, and then I will go through the output. Okay, this is building protobuf now. Okay, come on Windows, you can do it. Okay, now it's started to build the ATM server package, building it from sources. And finally, it will start testing the package in any moment. Okay, let's finish now. Cmake in Windows is so painfully slow. Okay, it worked. Let me go through the output, and I will explain. First, we can see here that we have the two profiles. We have the host profile, which is the 32 bits ATM context, and we have the build profile, which is the 64 bits my build machine. If we check here the requirements of this build, we can see that we have two different protobuf flavors. We have two different package IDs. We have this one, which is the host one, okay? And we have a different package ID, a different binary, which is the build required one. Okay, now Conan, as I didn't build protobuf before, in a typical case, okay, this protobuf will be already built in Artifactory for the two flavors. Okay, but I wanted to show the power of Conan, that you can do two different builds of the same thing in the same launch. First, it is going to build protobuf for the build context. It is running protobuf, not very relevant here. Then it will be running again protobuf for the host context, for the other configuration, two different build, two different binaries of exactly the same package. And here is where the important stuff starts. The ATM server, it starts to build. It calls the build method. The build method was calling protoc. If you recall protoc, okay, is using protobuf, and here we can see that this is using the protoc executable, which is 64 bits. This version here, 1929, for those of you who don't know it, is Visual Studio 16. Okay, so this is running protoc in my build context. And then this is creating the ATM server package. And finally, when it is testing the ATM server package, it will be running an executable. And this is the output of running this executable. We can see that when the ATM server is running, it's using protobuf package, but it's using the 32 bits architecture package. And it's using also Visual Studio 1916. For you, if you don't know it, is Visual Studio 15.1. And of course, this is also a statically linked runtime executable. So this is what I wanted to show you. Let's do a brief recap. Using build and host profile will be the default into 0. At the moment, this is an opt-in feature. If you don't specify the build profile, it is using the previous way. All of these of the build context and the host context will not be there. Okay, it's an opt-in feature, but it's really recommended that you start to use it now if you are doing cross-building, because this will be what will remain in Conan 2.0. The new tools that I've been presenting earlier, like Cmake toolchain, already use this model. If you plan to do any cross-building with the new toolchains, then you need to use the two profiles. This is already been, it's still experimental, but it's using being in production. There are companies out there using this cross-building approach, and we are using already ourselves in ConanCenter for cross-building the OS X new M1 architectures. We are using this approach as well. If you are using in your cross-build the legacy OS build and arch build settings, please don't do it anymore. Try to move this way, because this will be removed in Conan 2.0. And finally, I wanted to highlight that this is not easy to do with Cmake. The way that we can mix cross-building binaries for different contexts, I can guarantee you this could be a really nightmare to do it natively in Cmake. Okay, so thanks very much for being there and listening. I wanted to give you a few hints. You have the source code for today's presentation in this URL. If you have any question, you want to know something more about Conan, of course, for questions, the first resource in GitHub. Go to conan.io, and from there you can navigate to all those resources. GitHub for questions and support. The documentations, have a look, because the documentation is extensive and we are always trying to improve it. The blog, ConanCenter, for getting which packages are already available for the community. There is a very good training course, hands-on and free, in the JFrog Academy as well. And finally, the communities, both in the Include CPP Discord and in the Slack channel. The community there is amazing. They are really helpful. They help each other. They respond questions there. So it's a great community there. To finish, yeah, the video link, sorry, this doesn't apply. Please go to this URL or this QR code and rate my talk. If you, especially for the people that are online, the first 25 people who enter and rate my talk, they will get a free Conan t-shirt delivered to your home. Okay, so for the people there on site, you already got your t-shirts. But if for the people online, if you want a t-shirt, please fill the survey here, and we will send you a t-shirt. And finally, thank you very much. And if you have any questions, I'd love to respond.
Thanks, Diego. Can you hear me?
Yeah, I can hear you.
Yeah. Okay. Nice. Thanks, Diego. I think we can.
Thank you.
Everyone is awake, so the presentation was awesome, I think.
I don't hear you now, Marco. Sorry.
Oh?
You need to get closer to the laptop. Yeah, I don't hear you.
Ah, wow. Okay. It's a technical issue then. Can you hear me now or no?
Yeah, I can hear you now.
Okay. Now, I was saying that everyone is still awake, so I think the presentation was over.
Yeah, it was fast-paced, but I wanted to show these new things. So yeah, if you want to follow up, don't hesitate to ping me later. We can talk. I'm also pretty available in Slack and other channels, so feel free to contact me later.
Thanks. And I think we have one question here, right? Marco, you have a question? Okay, so I pass you my microphone.
No, I am afraid that mic is not working. You need to get closer to the laptop. Yeah, talk to the laptop, please.
Can you hear me now?
Yeah, great.
Okay. I already have a Sonatype Nexus repository in place. Is there a way to store Conan packages on this kind of repository instead of the Artifactory?
Yeah, that's a good question. Okay. So some major players, including Nexus Sonatype and GitLab, and also there is another like was CloudSmith or something. They provide support for Conan packages. So in case of Nexus, there is a Conan plugin. So you might need to install the plugin. And yeah, please try it. What I can say, and from my experience and the feedback that I get from Conan issues in the GitHub repo, is that the integration is not as solid. So as the Artifactory communication is free, if you try the Nexus, if it goes fine for you, then great, happy to know it. But if you experience any issue, give a try to the Artifactory CE, because the integration might be better.
Okay, thank you very much.
Yeah, you're welcome.
Other questions here in the room? Anyone? Let me check YouTube. I think we don't have questions on YouTube either. So let me check again. No, we don't have questions yet on YouTube.
Okay, no problem.
I think we don't have questions
pizza time.
On YouTube. Okay, yeah, we don't have on YouTube. We don't have on Slack. We are basically connected to 3 channels at the moment. We have physical channel here with people attending. We have Slack. We have YouTube. Maybe someone from the social networks as well. But anyway, Other questions, guys? No questions left. I know you want to go for the pizza. That's why you don't have questions. That's a strategy for going to the pizzeria.
I want some pizza too. Please deliver some.
I can send you some pictures of our pizzas.
Please do.
And no, that's right. And okay, I think Diego, I think that's all, because if people don't have other questions, I think we can set you free. And thanks again for the session, and also thanks to JFrog for all the gadgets, for the t-shirts and all the tiny frogs are here. And I hope to meet you again, to see you again in person, hopefully next year, because I'm confident for next year. Maybe we'll have that conference in Rome that we had to cancel 2 years ago, and I hope to have you maybe there, speaking again about Conan, about the other features that you're going to add to this great package manager. And so great. I think, folks, you can make again some noise for Diego.
Thank you very much. Thank you for inviting. Thank you very much, and my pleasure. So, hope to see you soon.
Thanks everyone for attending the session, and please give feedback to Diego, both on our link and also to the link Diego sent to you for the T-shirt. And so see you next time. Next month we have another session about cross-platform development from a guy from ThinkCell. So thanks again, Diego. Thanks everyone for attending. We go for the pizza now. You can stay with us on Slack as usual, italiancpp.org/Slack for getting access to the channel. See you next month. Thank you.
Thank you. Bye-bye.
Thank you. Bye.